Via stubs are going to have unwanted effect on your high-speed signal. When a signal is injected into a trace, it travels until it reaches the junction of the via stub in the trace. The signal splits, some of the signal continues to the receiver, while some continues to the bottom of the stub. At that point, it reflects back up, interfering with the original signal. If you were to look at this effect of a via stub over time, you'll see the original signal, and then later on in time you'll see the reflection noise from the via stub, which is typically undesirable. Drilling away the via stub eliminates the reflection issues. Do you need to back drill every via? No, of course not. It's always a trade-off between cost and performance. With that in mind, let's take a look at the back drill solution. This is just a sample design with several through-hole connectors going through many layers of the board that you're going to probably want to back drill. The first thing you're going to want to set up under the constraint manager, under the properties, under general properties, there is a constraint or a rule called back drill max plated through hole stub. This is a setting that tells the system how big of a via stub you are okay with until you need to start back drilling it away. So you can set the same value for every net in the design, or if you have high speed signals in your design that you're concerned with, you would want to set this max plated through hole stub property on those nets. That's going to become a key when driving the back drill. Once you set up that value, you can leave the constraint manager. Back in the design tool, you then need to set up the back drilling, which is under setup, back drill setup and analysis. This form is telling you what the back drill is going to do when you actually run the back drill command. Keep in mind that back drilling is something that your fabricator has to do. They fabricate every layer of the board, they stick it all together, and then they run it back through this process to back drill out these vias. So you want to have some cost consideration in mind when you do this, because it is extra fabrication steps. If you have not set up back drill and analysis before, the first thing you're going to see when you go to set up back drill is this form right here. It's going to ask you the deepest back drill layer to go from the top layer and the deepest back drill layer from the bottom layer. So you can set that up so you can say, I want to go all the way from layer top to layer 9 and all the way from layer bottom to the second layer from the top. You can then have it look at the design and try to achieve one of two goals. You can either have it try to minimize the electrical stub length, which could result in more back drills that your fabricator can do, but resulting in the least amount of via stubs as possible, or minimizing the layer pairs, which would then minimize the number from 2 layers that your fabricator has to drill through, which could be a lower cost solution. You have to look at your design and figure out the trade-offs for yourself. Once you do that, you would hit create. Based upon those settings, this form is then going to be populated showing you all the different back drill combinations that would have to happen to achieve the goals that you set up, to try to minimize the max plated through hole stub that you set in the constraints, and then the from 2 layers that you just told to back drill. So here you can see you have a start layer of top to layer 2P, then you have a must not cut layer. So this is basically telling the fabricator you can cut down to this layer, but you can't go all the way through to this layer. So you have that depth that's going to be eliminated, and how many plunges or how many different hits the drill machine has to take to eliminate all the stubs from that layer to that layer. And you have another combination from the top to layer 3 with this many plunges. Then looking at it from the bottom side, you have all sorts of different combinations going from the bottom to layer 9, bottom to layer 8, bottom to layer 7, bottom to layer 6, etc. And you can see how many plunges it's getting and how big of a via stub is being eliminated by that. Now, if you're looking at this and you think, hey, that's great, I'll accept that, you can then come down here and you can choose to back drill, and it'll go through the design and actually eliminate those via stubs from the design and replace them with keep outs and route keep outs, which I'll show you in a second. If you don't like that setup, you can go back to layer pair initialization, come back into this form, and then you could try to do it by minimizing layer pairs or minimize electrical stub length, and then once again hit create, and it'll go through and rebuild this table for you. If this table looks like you want to put into the design, you can then hit the back drill button, and you even get this notification here telling you that back drilling is out of date. So if you run the back drill command here and then go through your design and add more connectors to add a bunch of new vias, you'll want to come back into this tool to redo back drilling. It only takes less than a minute sometimes to back drill the design, and then it'll tell you that back drilling is now up to date. When you run the back drill command, it's going to do a couple of things to your PCB design database. It's going to add another back drill, so another hole in your design, which is indicated graphically by the back drill hole size. It's also going to add route keepouts around the back drill to prevent you from adding any traces or shapes too close to where that back drill may happen. The reason you want to have those keepouts is because these drills aren't always 100% accurate. They may wander a little bit, and so you want to have a decent amount of keepout around these drills and back drills so you don't accidentally drill out your traces or your shapes. You're then also going to get a back drill label showing you the start layer to the end layer and also the must not cut layer. Here's some examples of those back drill labels in that design after you run the back drill command. You can see you have the from to label, you have the keep outs, you have the finished hole size in the original hole size. Returning to the back drill setup and analysis, you have further control. For example, if you want to have different back drills for pins or pins and vias or just vias, if you need to go into that level of control. This form also shows you what the drill parameters can be with a nice diagram showing you the manufacturing stub length. This form here is where you can control all those things that I just showed you of the oversized pad diameter, the anti-pad, the keep outs that get added. Those things are all design specific. You can also, this is used to tell you what the error codes are going to be put on top of the back drill command or all the different pads and vias if it has any sort of issue running back drill. And then you have a couple of other settings to suppress back drill pads and display back drill flags automatically. So hopefully with that information, you can use the back drill command to minimize your via and pin stubs and improve your signal integrity and reduce EMI. Thanks for watching.